Before we looked at our next example, in the previous video, we did this problem, and I forgot to answer this question. Is the solution bounded? Well, obviously it is not, because this, for example, all of these arrows, they go infinitely on in this direction. There's no circle you could draw that would be infinitely big to encompass all of this. So this is an unbounded region. Is the solution bounded? No. Okay, I just noticed that this problem is exactly like one we did before, so I'm just going to tweak it a little bit. Let's change this into y less than or equal to 2 and x greater than or equal to -4. Let's use those two inequalities. So it'll be very similar to one we've done before, a very simple one actually. Well, y less than or equal to 2 means we are going to shade the lower half plane, and we're going to use a solid line. Because it's less than or equal, less than means lower half plane. It's got the equal sign in it, so we use a solid instead of a dashed line. Let's go ahead and do that. The line y equals 2 is a horizontal line that looks like this. And remember, we're going to shade below that, the lower half plane. And then this one, we'll do x equals -4, and we'll use a, let's see, we're going to do the, because it's a greater than, we're going to do the right half plane. So I'm going to put dashed line, and I'm not going to put RHP for right half plane. Let's dash the vertical line at x equals -4. 1, 2, 3, -4. And greater than means it would be the right half plane. So with these two lines, we've divided the xy plane into 4 regions. This region up here, this region here, and this region here. One of them needs to be shaded. It's the one that is in the lower half plane of the solid line, and the right half plane, maybe I'll write that here, right half plane of the dashed line. So it would simply be this region. So you can really aim the arrows any way you want to. I'm going to do it like this. So this is the region that we shade. This is the solution. It's also called the feasibility set, or the feasibility region. And the question says, is it bounded? And we know it's not bounded because it required my infinite arrows. The shaded region goes on infinitely. All right, let's look at number 10. This is the first one where we're dealing with 3 inequalities, other than the fact when we did a couple of problems where we had x greater than or equal to 0, y greater than or equal to 0, which meant we were using quadrant 1 only. This is not the case for this. So let's get all of these written in the correct form. That one already is, the first one. The second would be y greater equal -x plus 3. And then the third one would be y less or equal 4. So if this is 1, 2, and 3, we now have 1, 2, and 3. 1 and 3 are identical to this. Number 2, these two are equivalent. They have the same graphs, same solution sets. All right, so for the first one, the line would be y equals x with a solid line and an upper half plane. Because it's greater than or equal. So let me go ahead. Solid line means that. That's the line y equals x. has 0 as the y-intercept, and it has a slope of 1. So up 1 over 1, up 1 over 1. All right, number 2. We have, the line would be y equals negative x plus 3, and it's also going to be solid because it's a greater than or equal, the associated inequality, and it's also going to be an upper half plane. So let's see, the y-intercept is 3. 1, 2, 3. Slope is negative 1. That means go down 1 to the right 1. 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 So it would look like that. Okay, and that's an upper half plane as well. So far I know exactly which region we would shade. If you wanted to be in both of the upper half planes associated with these two lines, it would not be this region, it would not be this region, it would not be this region. This is the region that's in both of the upper half planes. But we have one more inequality. This one is y less than or equal to 4, so we're going to graph the line y equals 4, which is a horizontal line, and it's going to be solid because less than or equal, and it's going to be lower half plane. So the line y equals 4, 1, 2, 3, 4 would be this. Wow, this one's interesting. We have to shade only points that are in the lower half plane of this horizontal line, so below that line. We have to be above this line and above this line. So we get this triangle region. This is the only region that is satisfied, or that satisfies all of these inequalities. If you took any point, ordered pair inside the triangle, the xy pair, and plug it in here, and plug it in here, and plug it in here, all of these inequalities would be true. If you choose anything down here, over here, 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 at least one of these inequalities will fail. All right, is the solution bounded? Well, of course it is. Here's one. I could just draw a circle right around it. So therefore, this one is bounded. And we weren't asked to identify the corner points or each vertex, but it would be those 3 points, the 3 corner points that are touching the shaded region. Okay, the next question, we're not going to solve this. We're just going to set it up. It's a word problem, obviously. Fred purchases printers for his company. There are 2 types of printers, standard and high speed, which I'll probably use high speed for, HS. Okay, 2 types of printers. Standard is $79. High speed is $249. He may order up to 45 printers. He must buy more of the standard printers than high-speed printers. He may not spend more than $2,000. Write out the inequalities that describe the numbers of printers that Fred may buy. Okay, so what would the question be looking for? The numbers of printers that Fred may buy. That is 2 unknown, right? 2 unknown numbers. So we need to create 2 variables for those unknowns. Let's use x and y. Let x be the number of, let's say, standard printers, and we'll have y be the number of high-speed printers. So we need to, if we were asked to solve this problem, we'd need to find out what x and y are. All right, the instructions say write the inequalities. Well, there are 2 I could start off with that are very simple. You could not possibly buy a negative number of printers. So Usually I do these last, but I'm going to say x is greater than or equal to 0 and y is greater than or equal to 0. So this is one of those quadrant 1 type problems. Okay, so we have to make sure we use every number in this. Two types of printers. The X printers, the standard printers cost $79, and the printers, the high-speed printers, in which we need Y of them, they're $249. He may order up to 45 printers. That sentence right there gives us an inequality. He may order up to 45 printers. So he could order 0, 1, 2, 3, all the way up to 45, but he could not order 46. That tells us that X, the number of standard, plus Y, the number of high speed, is at most less than or equal to 45. Okay, that's how we find the inequality for this one. Next, he must buy more of the standard printers than the high-speed printers. Well, that's a very simple inequality. More standards than the high speeds. That means X, the number of standards, has to be bigger than Y, the number of high-speed printers. That was pretty simple. He may not spend more than $2,000. We have one more inequality. How are we going to do that? If you can't spend more than $2,000, that means something has to be less than or equal to $2,000. What is going to be less than or equal to $2,000? The cost. Well, what's the cost? If you're going to buy X standard printers and they cost $79 each, that would be 79 times X. Plus, if you're going to buy Y of the high-speed printers, they would cost 249 times Y. And that's it. We've used every bit of information in this problem to write out the inequalities associated with it. The number of standard printers greater than or equal to 0. Number of high-speed printers greater than or equal to 0. The number of printers, which is X plus Y, the total number of printers, is at most 45, less than or equal to 45. The number of standard printers is greater than the number of high-speed. That was this inequality. And finally, the cost, total cost, has to be less than or equal to $2,000. Well, how much do you pay for your printers? $79 for each one of the standards, and X is how many standards you're going to buy. Y is the number of high-speed printers. Those are $249 each. So that sum has to be less than or equal to $2,000.